based on the concept of accessibility, communication, classes of states, we're going to introduce a new concept referred to as irreducible Markov chains. All right. So an irreducible Markov chain, how do you spell that here? So it is defined to be a Markov chain with only one class. Okay. So let's look back at the two example Markov chains we had in the previous video. In this video, in the previous video, we saw that 1 could communicate with 2, 2 could communicate with 3, and 1 could communicate with 3. All right. Because all the states could communicate with each other, there was only one class, 1, 2, and 3, and that class includes all the possible states. Now let's compare that to this guy over here, this more complicated Markov chain. You might recall that the classes we actually had 3 of them. The first class was 1 and 2, because they could communicate with each other. The next class included state 3 by itself, and the last class was just state 4. Okay. So in this first example, we only had 1 class, while in this second example, we had 3 classes. So in this first case, we would say we have an irreducible Markov chain. Well, in this latter case, we do not have. So this is not an irreducible Markov chain. All right. And so this idea of irreducibility is going to be very important when we start talking about limiting probabilities.